Alright, it's time to add the enemy attack to this Final Fantasy VI battle project, finally. So putting the cherry on top of this made me realize I needed to rethink the battle system and the workflow. And this is a good case study in the value of good practices. It's definitely more difficult to undo what you've already built than it is to build it more slowly. So I do recommend implementing like at least a partial class diagram, which is what I've done. And just plan your workflow and what's going to happen as much as you can before you actually implement it. In programming, there's always going to be this sort of thing, but at least that'll help minimize that. So this tutorial is mostly going to be broken up into 4 sections. I'm going to cover queuing up the character attack, queuing up the enemy attack, and then executing the character and executing the character attack and executing the enemy attack. A big design philosophy change, which is obvious in hindsight, is separating the queuing from the actual execution, because otherwise you won't really be able to have more than one battle action queued up at a time. So one of the major differences is I was storing everything in just game state. And my idea behind that was if I've got an individual state for every single situation, while the states are kind of cumbersome, you don't have any chance of mixing 2 states up when you don't want to, like everything's accounted for. That doesn't work in a battle system like this, mostly because of the selection. So what I've done is I've separated the selection states, like whatever you're selecting, whether it's an object, a character, an enemy, or a menu, whatever. Those states are in their own enum. And the other game states like battle 1, battle action, whatever, they're in the game state that was already there. Again, the reason we need to do that is because if you want to be able to move through the menu and select something while an attack is going on, for example, those states can't be mutually exclusive. Another big change is the characters and enemies list are now a battle game object, which is my own class, and that class is going to store all of the information that is, useful for battle, because before I was controlling selecting and stuff by index, and that gets annoying and confusing when you've got characters might be wounded or an enemy disappears. The list indices are no longer sequential. Now in the UI, the cursor is still going to use an index and based on the numbers that we put on the labels and stuff in the UI. That's the same as before, but when selecting objects like characters or enemies, it's not going to use an index. We're just going to have the object stored in this object. So the node is the node 2D, the actual 2D object in the scene. Entity data is going to be their database information, which is their stats, character or enemy, etc. Is queued is an important one here because that's part of separating the concern. So when an action is queued up, then they won't get queued up again because we're going to set this to true while it's waiting to be executed. I want to mention the repository has tracked this, so I made all of these changes in new battle queue logic. Before I did that, I made a commit to save the original battle logic here, so if anyone's following the code or whatever, the information is here, and I've now merged this into the main branch, the new logic that is. This part is going to be mostly when their ATB gauge is full, and in the character's case it's a little more. They have to confirm whatever menu choice they're on, obviously, but the enemy is just going to queue themselves up once their bar is full. And both of those things are going to happen in the battle controller script. So if you're using VS Code or VS Codium, which I am here, this is a nice feature on the right over here where you can define a region like this, and then end region, and then you can see those regions over here. That's very helpful. Some of this probably could be split out into more scripts, but anywho. So you'll see the character battle timers and the enemy battle timers. That's the part we're going to talk about for the queuing up. This is the same up here. We're just detecting if their timer bar is full, incrementing it, whatever. When it is actually full, and this is important, like I said, and the character is not already queued, so we don't allow them to infinitely stack actions up here. So we've brought up the fight menu, and then this just sets the active character and assigns the cursor parent for the the finger cursor. So the enemy battle timers are handled here, but now we've got the fight menu. So now we're going to go to the character action region down here. So once that fight menu's up, just a refresher, the cursor pressed event, which the hand cursor script will send the event whenever the cursor is pressed and send whatever button is pressed or the command as I have it set up. So this is in previous tutorials and it's not too important to this one. I'm just following the workflow through. So here, if the command's fight, that sets the status here, the selection status now to fight selecting target enemies. If we go down to character action here, we're still in that cursor press method, so you note that up here. This is just handling that input. What we're doing here is detecting if they press the accept button while they're already selecting, so that means they've selected that target. So again, much of this is the same, except I got some redundant code out of here and cleaned it up a little bit. But the essential change is right here. We're adding a battle turn. This handles which objects, whether it's characters or enemies you're selecting. But here we're adding a battle turn object, and that battle turn object is going to store all of that information that's important, right? So like here, this is the static variable, the Q, which is going to hold all the actions. The other properties in here are going to store those things that we need to know when we execute the turn, including the targets. Now the target object, that's storing what's going to happen to that target. Some of these I'm not using right now, and you would need to add others to have everything accounted for, but then you just change that in this class. So that way, if you go back to make a change, then instead of rewriting the structure of the code, you've got your own flexible class that you can modify and put whatever you need in there. This is pretty straightforward. We're just saying, hey, the turn type's party. It's targeting the adversaries if that's what they're doing. The active character is the one, that we're selecting the menu on when the timer bar gets full. Ability effect is something for both the character and the enemy. I've changed how it works a little bit. This is just going to be the effect that spawns on the target, and it's going to be, a slash or the scratch or whatever that may be. So once we've created that battle turn object, we add it to the battle queue. It's a static variable, so you don't need like an instance or a singleton in this case. You just pick the class, the variable, and then add that object. And we handle the active character nonsense, and we also set the selection state back to none, but we do still assign the cursor parent to the fight menu container back to where it was, because we're not selecting an object anymore. If another character comes in and changes that right away, that's fine, but you can't leave the cursor trying to select an object once it's executed, of course. So then this not selecting target event, that's again covered in previous tutorials. The hand cursor will receive that and switch the mode from menu selection to object selection and vice versa. I shouldn't say and vice versa. There's a different event. Selecting target is to make it object selection. So, and that's what happens here. That's basically the process of adding character action to the battle queue. So now enemy action. Something important to note is this base enemy action class. This is an abstract class, which means you can inherit from it and override the methods. This is to solve the problem of you want enemies to have customizable behavior. You want different enemies to be able to do different things. Obviously, you're also not going to want to write a 50,000 line script or whatever it ends up being to account for each individual enemy's behavior. That would be horrible. So this is just one approach to do that. So this is the base enemy action script so far, and again, this would likely expand as you built more stuff into the system. This is stuff that's going to happen for all enemies. And the difference between an abstract class and an interface is like an interface which just has properties that you would inherit from any object. The abstract class can actually execute a method. So the example being here, the base enemy action, every enemy action is going to have a Q turn, which, queues up the turn, sure, and execute turn, which is what happens when it actually gets fired off from that battle queue. Attacked is because some of these enemies will have behaviors based on what happens to them when they're attacked, and you can then run that code for that specific enemy when they get hit. So let's take a look at the Rhinotaur class. So for Q turn, on the first turn, they have a 1 in 3 chance of doing nothing at all, apparently. And then similarly, they have a 1 in 3 chance of attacking with Rush. So I just get a random number for the probabilities here, next double. By default, this is between 0 and 1, so you can use it as a percentage calculator. And this is the normal attack, and you can see the damage. I just initialized the variable up here and then just set it depending on which one of those things happens. I did not change the effect of this yet. So like right now it's just the scratch no matter what, and like I said, it's not fully in there, but it works. This is just going to select a random enemy, and you can see all we're doing is getting a list of valid targets here. The is valid target is true. You can set that to false if they're wounded, or if they have the dragoon boots or whatever it was and they're jumping. Of course they're not a valid target, so you would handle it with that variable there. And then this very similarly is just getting a random number up to the number of valid characters there are, and then just pick the index out of this list which we just created. Since we just created this list for the purpose of picking a target, then of course that one you don't have to worry about indices so much. You can just pick that index and do the same thing next time. Battle target objects, I'm just handling this in list because obviously you want the flexibility to be able to have more than one, so it's going to loop through the list where appropriate, but it's only going to be one for now. And since we're creating a battle target object, you see I'm only putting what the target is, the object, and the damage HP. If you wanted this ability to do more than that, then you could put in the damage MP or replenish if it were a healing spell or something like that. Again, here's the battle target class, so you could use any of these properties, or of course add any that you want as well. So we've picked the target, we've calculated the damage. That's essentially all we really need right now. So here, same deal, we're adding that battle turn object, and this is what's important. We're using these objects to try and decouple this as much as is reasonable, so that you can use these objects regardless of whether it's a character, an enemy, or attacking one or the other. If for example, if we had muddled the Rhinotaur, then this wouldn't be adversaries necessarily. You might have a chance of that being allies or all. I have all in there for stuff like Murton. And similarly, like I said, the ability effect with the sword, it's going to be a slash, and I'll show how that works. But in the Rhinotaur's case, it's just going to be that triple red slash. The scratch will show it. So we did cover this with the Lightbringer before. It's the same strategy. We're just going to have an animation player which goes through whatever is there, and you just position this so that it goes onto the character where you want it to. It's going to be added as a child, so the scene will go right onto the character, and then the animation, you just make sure you press this over here so the animation plays when the node spawns, and then Q free gets it off. So once you've spawned it in the right spot, this takes care of itself. The animation goes, the sound plays, and then it disappears. So, and again, if you wanted specific effects for the Rhinotaur, then you just put them in the Rhinotaur script. But again, the Rhinotaur script inherits from base enemy action. So to kind of illustrate that point better, when the turn actually executes, I haven't put any customized behavior for the Rhinotaur, so I just put base, which is the base class that it's inheriting from, and execute turn. That's why you can do that with like process or ready methods. Those are overrides to one of Godot's abstract classes. So what we do is the Rhinotaur has the Rhinotaur script attached to it here. So that way, when we get the node, you can cast the node as the type of the attached script. And we're going to cast it as that base enemy action type, because that way you don't have to change that for every single enemy that you call this on. So Q turn, I should actually add that. So a good example here is base Q turn. All that's going to do is increment the turn counter. A lot of enemies have logic based on how many turns that have elapsed. So it does the base action, and then it does whatever is customized to the Rhinotaur right here. And when they're attacked, one of the things about the Rhinotaur is that if you attack them with a spell, they have a 1/3 chance to respond with Megavolt, which is basically Bolt 2. So that could handle this. You would set that variable. Again, I did not implement the actual behavior yet, but the structure is here so that the logic will say, okay, this is when this is supposed to happen. So that's this part of the diagram here. We've gotten the enemy to add their attack to the battle queue variable here. And this is just a note for what I was just talking about. Like, this base enemy action script will be inherited by any particular monster script that's attached to their node. And this here, like the execute turn, when this actually happens, it's going to call that execute turn method on there. That's why I have that arrow there, just as a reminder. So we've gotten them into the queue. I'm going to go through the character execution, and this is going to start in the battle turn script regardless. So battle turn here, this process method is going to constantly check if we're not in a prohibitive state, so to speak. So like if there's not already a party or enemy action going, or obviously the battle's won, it's just going to ignore it, return, do nothing. So if we're not in some sort of state where we should not do it, basically, if the battle queue count is greater than 0, meaning something is there, then we're going to execute the next turn. So the active battle turn, which is stored up here, because we kind of need that later, it's going to just get the first item in the queue. And this is just the separation of if the turn type is party, it's going to do the commence party turn for our character, which is what I'm going to go over first. Otherwise, it's going to call that script. Since we were talking about it, I should mention that right here, this is how you would do that. You have the initiator's node, the node 2D, right? So then we're really after the Rhinotaur script here, but we're casting it as the class that it inherits from, so we don't have to write Rhinotaur, Belmadar, 50 different enemies here in this code. And you pass in the enemy itself as an argument, and we'll come back to that. So commence party turn, all this does is we are triggering the attack animation on the character. Now this is a little bit of review, but the reason I have the attack animation be the catalyst for all this is I don't want the weapon to appear in the slash and all those dominoes to fall until Locke's at this point in this animation. So this is the attack animation, so I again just used naming convention there. So he gets into that ready stance, and then there's like a second or something delay before he actually lunges forward with the sword. So there's a very perceptible delay there, and I want this call to this method to be the catalyst for when the sword appears and the slash and such. So the fight animation is on the character controller because that's what's going to be attached to lock, and that's all that's getting called here. So we're getting the active battle turn. Again, we've stored everything in those battle game objects to make this easier. The initiator is going to be lock, or Terra, whoever it is, the node 2D, and then we get the battle animation player, which is what we just looked at, and then we're just going to play the attack animation, and that sets everything in motion. So on the character controller, that once he's halfway through his lunge there, fight animation is going to get called, the weapon gets spawned. So before I had yet another script to be called on the sword itself, which would spawn the slash if I remember correctly, or the damage text, and that
yeah.
I didn't want to do that, and I don't even love doing this on the actual objects, but it's much better. So the spawn point is obviously where you move that on the character. You can control where that sword appears. It just instantiates the weapon scene. And the question now is, where is the slash that appears on the enemy? So again, since we queued that up, just a quick look back here in the battle controller. Back when we did the queuing, the weapon attack scene gets that weapon underscore attack, again, naming convention, and then that's added to the battle turn object down here, the weapon attack scene. So the attack slash is in the battle object here. And this is where I changed how I handled that timing. Before I had like a 0.2 second delay in the animation, which called another script. Sucks. So the battle turn, I have a singleton instance of the battle turn so that I can call that method and, again, access the Godot node stuff. So we're going to say damage targets 0.2. That's going to be however long you want to delay between the point in the animation and the actual effect on the target. And a good reason to have it here is because the enemy action is going to call the same thing. So whatever delay you want that makes sense between those effects, you pass into this method. So let's go there. We are back in battle turn, and damage targets what's really finalizes all this. And this is the delay right here. So that's why we pass in delay seconds. This just does the quick cheap timer and awaits the timeout signal for that timer for however many seconds you put in there. So right at the start of this, you have that delay, because otherwise everything happens instantly and it looks completely wrong and is. So same idea here. We're iterating over each of the targets, but now there's only going to be one. And here we instantiate that ability effect, the slash, the scratch, whatever it may be, on the target. Damage text, we all know what that is. Again, you can always peek if you're going through here. It's just creating the object, putting it on there. And this is where, at least I made the decision to have this method handle enemy or character. So here we're checking if it's an enemy, do this, and if it's a character, do this. So right now we're focusing on character. You can kind of see it happening in both, obviously, but the character is a little bit different because the character's data we have to persist in the database, whereas the enemy, you just load their stats when the battle starts, and when they're dead, they're gone. You don't have to store that. So we're passing in the entity data and the damage HP. Obviously, you would expand this to handle the other situations like spells and whatever. So this actually uses the database to get their current HP. Sets the this is a variable for their new HP, which is going to either be 0 or something less than their current HP. And if it's 0 in the end, we add the wounded status. I haven't handled animating and then logic after that, so I just put that here for now. And then the database handler update character with the new object that we've just updated. That's how that works. So this event damaging character is subscribed to in the battle controller once again. Over here now, right? So this is what I showed here. The fight animation spawns, and then the damage targets method. So here we have damaging character. It fires an event, and then we're going to update that in the battle controller. That's just the menus and typical stuff. And there's not much of this. This probably doesn't even need to come over here, but we're just updating the character stats. This updates the labels and everything. So now that will make this a little easier to understand, hopefully. If we go from the enemy attack, you've kind of seen most of it alongside that code. But just to go through it, this base enemy action is going to be what's happening. So again, for execute turn, right now the Rhinotaur just uses whatever's in base enemy action. And that here is just going to do the flash effect, which we've shown before. And right here is just how long you want the flash effect to go on for, because it's just setting that shader value back to false. Then we're going to call the damage targets. So he's like, hey, I'm going to attack you. And then we're going to put a 1 second delay. I had hard coded that before after the flash. So that way, same idea. So if we come back to damage targets, all that's going to happen, all this stuff is the same up until here. If it's an enemy, then we're going to update their object, And again, since this is not being persisted in the database, all we really have to do is affect the object which has their data, HP, MP, or whatever, and you don't have to like write it to the database or anything, because once they're done for, they're done for. And then here is where we again cast as the base enemy action attacked, and I just put null in here because you want it to take in the ability that they're attacking with, because that's obviously going to matter if there's something relevant that they're going to do in response to it. But since I haven't really done anything with it, it's just passing in null. It's there as a placeholder. And again, here I'm not using these three yet, but you have the code ready to take care of it when you do something like a heal spell or whatever you're doing to that enemy. It's going to be in that information in that battle game object. So here, again, we're decoupling it as much as possible. We'll skip over this if it's an enemy attack, but all this stuff is going to be the same. Here we're saying, okay, they're no longer queued, obviously, because they just attacked. Same thing with the progress bar value to 0. I think I have that redundant somewhere, don't mind that. And then we're removing the active battle turn from the queue. So now this turn is done. And then if there's something else in the queue waiting, we just set the active battle turn immediately to the first one in the battle queue after we've popped that one off. Otherwise, we just set it to null because now there is no active battle turn. This speaks for itself. We update the game state to battle because no action is occurring right now. So for the next turn, if there's no active battle turn and the party or enemy is not moving for the most part, then it can continue and execute the next turn in the queue. If you've seen Octopath Traveler, I think that's a great example of how you might make this useful towards a more complicated battle system than even Final Fantasy had. In that game, they actually show you the stuff that's queued, and that's part of the strategy, which makes it even more of a no-brainer to use a queuing system, to my chagrin. But that's pretty much it. Like that's all 4 of those sections in a slightly disorganized Venn diagram fashion. And what would it be without a little bit of a quick playthrough? This is going to be quicker too because the stats are actually calculated. I don't even know if it's right, but there we go. 0? What gives, man? That was interesting. I wonder if that's like the... You know what I bet happened there is I bet the first attack... Yeah. I'll say it in a minute here. I added the fade out, so I'll go over that in another tutorial. So I think what happened there is the chance of the Rhinotaur not attacking on the first attack happened, but I didn't actually put in logic for it to not attack at that. So yay, we get to see a bug live. Yet that must be it. So here I started off the damage variable as 0 because you need to initialize it in C# if you're going to set the variable only in like if statements, because otherwise there's a chance it doesn't exist, and C# doesn't like that. And here, so if the random number is less than 0.33, you notice I don't change the damage variable, so none of this code ran, but all the rest of the code still ran. So that's why that happened, and that would just be a quick modification. You could set another variable like you have will respond with megavolt. You could set another one that's like won't attack and then just skip that code. So hey, cool.